Welcome to ChemDoodle Shorts. I'm Mary, your ChemDoodle Pro. Let's learn about carbonyl-containing functional groups. Functional groups have distinct chemical properties and reactivity. As such, they can be used to predict a molecule's behavior and reactions. One of the more ubiquitous moieties is the carbonyl group. A carbonyl group consists of a carbon atom connected to an oxygen atom with a double bond. The carbon has a partial positive charge, while the oxygen has a partial negative charge, making the carbonyl group polar. The carbon is also an excellent electrophile, so carbonyl groups typically undergo nucleophilic addition and substitution reactions. Let's learn more about carbonyl-containing functional groups. Let's start with the most basic one, aldehydes. An aldehyde is composed of a carbonyl group with a hydrogen bonded to the carbonyl carbon. The R group can be a hydrogen atom, alkyl chain, or aryl group. The simplest aldehyde is made up of the aldehyde functional group and another hydrogen atom. This is commonly known as formaldehyde. Replacing the hydrogen with a CH3 methyl group produces acetaldehyde, which is its common name. Otherwise known by its systematic name, ethanal. Note the ending -al to indicate an aldehyde. Similar to aldehydes are ketones. The ketone consists of a CO carbonyl group bonded to not one, but two carbon atoms. These R groups can be the same or different. Unlike an aldehyde, the carbonyl carbon is not attached to any hydrogens, so the carbonyl is located in the middle of a carbon skeleton, rather than the end. The smallest ketone includes the carbonyl, bonded to two CH3 methyl groups. Here, the R groups are the same. Notice the ketone carbonyl is located in the middle of the carbon chain. This is unlike an aldehyde carbonyl, which is found at the end of a carbon chain. This ketone is commonly known as acetone, the primary ingredient in nail polish remover. Under systematic naming conventions, this is known as 2-propanone. The R groups of a ketone can be part of a ring as well. In this molecule, the carbonyl group is connected to a 5-carbon ring, a cyclopentane. This is cyclopentanone. Note the suffix -one to denote a ketone. The next functional group is carboxylic acids. A carboxylic acid combines a carbonyl group and an OH hydroxyl or alcohol functional group attached to a hydrogen, alkyl, or aryl group. Carboxylic acids are weak acids that are polar and participate in hydrogen bonding. A 2-carbon alkyl chain with a carboxylic acid functional group at the end is acetic acid, the main component of vinegar. Its systematic name is ethanoic acid. The ending oic acid specifies a carboxylic acid. A derivative of carboxylic acids is esters. An ester is similar to a carboxylic acid. It has the CO carbonyl functional group. However, instead of an OH hydroxyl group, it's an OR alkoxy group, where the oxygen is bonded to an R2 alkyl or aryl group. R2 cannot be a hydrogen atom, as that would turn the ester functional group into a carboxylic acid. R1 can be a hydrogen atom, an alkyl group, or an aryl group. Esters are ubiquitous in nature. Tributylene is a triglyceride that naturally occurs in butter. There are 3 ester functional groups in it. Esters are also known for their pleasant odors and flavors, commonly used in fragrances and as flavorings. This ester is ethyl hexanoate, notable for its characteristic fruity pineapple fragrance. An ester is often formed from an alcohol and an acid, so this is reflected in an ester's systematic name. The first part of the name is derived from the parent alcohol, here the R2 group. A 2-carbon alkyl chain is ethyl. The second half of an ester's name comes from the parent acid, here the R1 group including the carbonyl carbon. A 6-carbon acid is hexanoic acid. Since this molecule is an ester, the second half of the name becomes hexanoate. Altogether, the combination of the suffixes -il and -oate are indicative of an ester. A functional group that incorporates nitrogen and carbonyls is amides. An amide merges a CO carbonyl group with an amine group. The amide functional group is connected to an R1 group, where R1 can be a hydrogen atom, alkyl group, or aryl group. Like amines, there are a few different types of amides. In a primary amide, the nitrogen is bonded to 2 hydrogen atoms. Let's consider this amide. In this molecule, the amide functional group is found at the end of the carbon chain, making this a primary amide. In a secondary amide, the nitrogen is attached to one alkyl or aryl group and one hydrogen atom. Removing a hydrogen and adding an alkyl chain to the nitrogen now makes this molecule a secondary amide. In a tertiary amide, the nitrogen is bonded to two alkyl or aryl groups. Removing the last hydrogen and adding a second alkyl group to the nitrogen makes this molecule a tertiary amide. In amide nomenclature, the uppercase italicized N denotes a substituent on the nitrogen atom. Notice also the suffix amide conveys an amide-based molecule. Let's continue on with carbonyls and halogens, the acyl halides. An acyl halide or acid halide is made up of a carbonyl group bonded to a halogen, which can be fluorine, chlorine, bromine, or iodine. Like the previous functional groups, the acyl halide group is connected to an alkyl or aryl R group at the carbonyl carbon. In this acyl halide, there is a 2-carbon chain with a terminal acyl chloride group. This is ethanoyl chloride. The ending oil halide designates the acyl halide functional group. You've learned that there are important functional groups that incorporate a carbonyl group. The most basic ones include aldehydes and ketones. Incorporating a single bonded oxygen yields carboxylic acids and its derivative esters. Integrating nitrogen with a carbonyl group produces amides, and acyl halides include halogens. Being able to identify these functional groups can help you to name a molecule and predict its chemical properties and reactivity. Thanks for watching ChemDoodle Shorts.